So let's start talking about addition of fractions. Let me just remind you very quickly of what a fraction is and how we defined it. So if we write a fraction like a third, so here's a third that I write as a fraction, what I mean really is that I have a whole that I can represent in some way. I'm going to represent it as a bar. I'm going to break it up into three equal pieces, and one third would represent that I take one part out of those three pieces. So this represents one third. Okay. So the important thing to remember is one out of, so it's going to be one out of three equal pieces. One out of three equal pieces. Okay. Equal is important. Okay, so there we go. So now if I talk about a third of a liter of milk, let's say I want one third of a liter of milk. So what I mean is here's a jug of milk. So here's a jar of milk. Here's my jar of milk. It's a liter. So I'm going to break it up into three equal pieces. They may not look equal. Okay, this looks really small. So maybe I should make this a bit bigger. So now I'm going to have here. So now there are three equal pieces, and I'm going to take one out of those three equal pieces. This is, if this is going to be 1 liter, this would be 1/3 liter of milk, right? Because this is 1/3 of that milk. Okay, and please note that I can certainly take 1/3 of a chocolate bar, 1/3 of a liter of milk, or other things. And remember how we abstracted away from when we were kids. We thought about 3 apples and 3 pens and 3 erasers and 3 bananas and 3 pages and 3 books and 3 footballs, and then we eventually got the abstract concept of 3. So we had very concrete objects in the real world, and then we moved from those very abstract ideas to the abstract concept of the number 3. Similarly, the same applies to 1/3. So we have a 1/3 of a bar of a chocolate, we have 1/3 liter of milk, we can have 1/3 of a cookie, we can have 1/3 of a cake, we can have 1/3 of an apple, we can have 1/3 of an orange, and then eventually we get to the idea that 1/3 is a number that is abstracted away from this concept of 1/3 apple and all those things. Okay, so now if we want 1/3, let's say somebody wants 2/3. So if you want 2/3, well then you can take the second third also. So let me randomly take this thing, and this is also, so this would be 2/3 of a liter of milk, right? Because I'm taking 2/3. So this was 1/3, so this was 1/3, and this was the second third. So I took 2/3 of the liter of milk. Okay. So now please remember, this is just the concept of a fraction that we have. Now please remember, we had this idea that we know that something like 2 plus 3 equals to 5. And what this equation really embodies is that if we have 2, I don't know, chocolates or apples or something else, and then we add 3 more, let's say we add 3 more. So what we're going to get is, we are going to put these things together, and what we're going to get is, we're going to get 5 of these. So we're going to get 1, 2, and then I'm going to put them together, 3, 4, 5. So these are 5 chocolates or whatever it is. And after adding 2 erasers and 3 erasers, you get 5 erasers, and 2 pencils and 3 pencils, you get 5 pencils, and 2 pens and 3 pens, you get 5 pens, and 2 monkeys and 3 monkeys, you get 5 monkeys. We can abstractly say that 2 plus 3 is equal to 5. Similarly, now we can play the same game, and we have a bar of chocolate. So let's take a bar of chocolate here. So here's a bar of chocolate. Here's my bar of chocolate. And let's say I want to divide it into fifths. So let's try to divide it into fifths. 1, 2, 3, 4. And this is very long. So I have to erase it so that I have a semblance of equality. So now I have fifths. So let's say first a friend of mine comes and I give her a fifth of the chocolate. And then another friend of mine comes and I give him maybe 2/5 of the chocolate. So here's me giving away 2/5 of the chocolate, because each one of these was a fifth. So this was 2/5. Remember, this was 2/5. This was 1/5. So now you can see, if I add 1/5 to 2/5, then I'm going to just count the number of fifths, and I have 1, 2, 3, right? So this is going to be, if I'm counting fifths, so this is going to be 1, 2, and 3. So I'm going to get the answer, which is going to be equal to 3/5. So I'm essentially counting and doing nothing else. So this is just exactly like what we learned to add. We are really adding 1/5 and 2/5 to get 3/5. Exactly like when we added 1 orange to 2 oranges to get 3 oranges. So now our denomination is no longer in orange, but now is a fifth. That's the only difference, okay? And now similarly, as we did earlier, if I want, I can add maybe 1/7 plus 2/7 plus 3/7. So now I'm adding sevenths. So I have 1/7, and then I have a 2/7, so that makes 3/7, and then I have further 3/7, so I'll get an answer which is equal to 6/7. And the reason why this is 6 is because what I'm really saying is it's just 1 plus 2 plus 3 is equal to 6, because I'm just counting sevenths, and I get 6/7, just as when I was counting apples. 1 apple plus 2 apples plus 3 apples led to 6 apples. So that's how we add fractions on the same denominator.